How can we do physics in higher dimensions? Let's say we are in the first dimension. So in other words, there are only two ways to move, forwards and backwards. Let's say there is a line that weighs 1 kilogram. How much force would we need to give it a velocity of 1? Because force equals mass times acceleration, and both the mass and acceleration are 1, then the force is 1 times 1 equals 1. This means that in order to get it moving forwards at 1 meter per second, we must push it forwards with 1 newton of force for 1 second. Very simple, right? Well, let's add another dimension. Now, there is a square that weighs 1 kilogram. Now that there is a plane of rotation, we can push it in 360 different angles instead of just 2. Let's call this angle theta. In addition, the second dimension allows for our object to rotate. If we push the square at an angle, then depending on how sharp the angle is, some of the force would become rotational. To find the translational force, find the sine of the angle at the contact point of the force makes between the square's center of mass. The rest of the force would be rotational. For example, pushing a square at the midpoint of an edge would make all the force translational, as the midpoint makes a right angle with the center of mass. However, pushing a square at 90 degrees anywhere higher or lower would cause it to rotate, as the angle of the contact point to the center of mass is not 90. Finally, to find the coordinates that the object is at, since there are two dimensions, trigonometry must be used to calculate the x and y movements of the object. Now, let's look at the third dimension. Since it takes a minimum of 2 angles to find the point of contact on an object, like spherical coordinates, all forces have 2 angle components. We will call these angles theta and phi. So, if a force was applied to the corner of a cube at 90 degrees for both theta and phi, then since the angle to the center of mass is 45, and 90 is 45 more than 45, sine 45 of the force would be used to move the x, y, and z coordinates of the cube, and the rest of the force is split evenly between the two planes of rotation. Now, let's move on to higher dimensions. It really isn't that difficult, as you only have to add more numbers. For the fourth dimension, you would need a minimum of 3 planes of rotation, since hypersphere coordinates need 3 angles. So, a force would have to have 3 angle components, and when it comes in contact with an object, the object would rotate in 3 different planes of rotation and move in 4 different axes. It's that simple. Now, let's try it with the 10th dimension. It would have 9 planes of rotation, as you need 9 angles to identify the angle the point of contact makes with the center. When a force comes in contact with the 10D hypersphere, it will cause it to rotate in 9 different planes and move in 10 different axes. That is how you would do physics in higher dimensions. The calculations are the easy part, but visualizing and displaying higher dimensions is the real challenge. Anyways, hopefully you enjoyed this video, and see you next week. Bye.